Hey everyone, and welcome to the VMware Cloud on AWS Technical Deep Dive. I'm Brian Graff, and I'm the Senior Technical Marketing Manager for VMware Cloud on AWS at VMware. In this webinar, we're going to discuss a number of the aspects of VMware Cloud on AWS in a very technical manner. But before we get into that, we're going to basically set a framework for everybody to really, be on the same page as we go through this. So with that being said, everybody understands that we're headed to a multi-cloud world. The idea here is that unlike before, when we had a binary decision to make whether or not a workload would go either on premises or to the cloud, we now have the ability for our customers to choose both. And in this same idea here, we're able to go ahead and say, when you do deploy to, for example, a hybrid cloud, you have the ability to tie in with AWS services. It's no longer binary between which platform you're going to deploy on. It also now includes using the best features and services from both VMware and AWS. So that being said, a lot of our customers talk to us, and a lot of the issues that they run into when building different clouds or expanding to the cloud is operational consistency. By running workloads on premises and then running them in the cloud, there's generally additional operational inconsistencies that occur because you're running on different platforms. And the same thing can be said about your skill sets and tools. All right, different clouds mean you use different tools, you use different APIs, you'll have to rewrite all of your scripts. And then going into controls and security, right? Each cloud is managed in a different way. This means that for every cloud that you have running workloads on, you're really going to have to figure out how to manage and control each of those individually as separate clouds rather than as a whole. Obviously, our customers want to be able to run their production workloads and high performance workloads wherever they choose. And the other challenge that we see is just the compatibility with applications. Now, some of those may be latency sensitive applications. Some of them may have issues with privacy, data sovereignty. There's a number of different issues here that make it difficult for our customers to really adopt a cloud or hybrid cloud. And that's where VMware Cloud on AWS comes in. So with our partnership with AWS, we've been able to go ahead and create an environment for our customers, as you'll see here, that runs on the AWS global infrastructure. And all of that is using the VMware software. So on the left-hand side, you can see your on-prem data center. All right, this is your on-premises environment where you are in charge of everything from the power and cooling all the way down into the applications. On the right-hand side, if we stretch this, you can see the AWS services. Now, if you've been working in AWS at all, this is where your workloads would be residing. And VMware Cloud on AWS sits right in the middle of all of those. So the great thing about this is because it's part of the Amazon global infrastructure, we're able to tie into those native AWS services and provide a truly hybrid approach to not only the environment, but to the applications themselves. And we'll talk about that a little bit more here later on in the webinar. But what you'll see here, as you can see highlighted in red, is that ESXi, the hosts running your virtual workloads, are all dedicated EC2 hosts. And these are not EC2 instances. These are not nested virtualizations going on. This is dedicated hardware for the customer, spun up with vSAN, NSX, vSphere, and there's several other additional pieces of software that you can grab as well. And there's a certain level of operational consistency we'll talk about with hybrid linked mode in a few slides, but you'll see this dotted line around both the vCenter on-premises as well as the one in VMware Cloud on AWS. And this allows you as the customer to be able to see and manage both environments from the same vSphere client. So what else makes this unique? The fact that we've partnered with AWS means that we're able to leverage any of the regions that they have presences in all over the globe. And as you can see from the first column on the left, you can see actually the first two columns now, we are in a number of different regions all over the world. And as of VMworld 2018 in August, Pat Gelsinger was up on stage and announced our roadmap for the rest of 2019. So essentially anywhere that Amazon has a region, we plan to be there as well. What this means for you, especially if you're a global company, is you can geographically spread all of your environments without the need to have on-premises data centers of your own or to expand to those. It's really up to you, but the flexibility is there, and we're leveraging Amazon's global footprint to make this easier for you, the customer. So the last slide before we go into more of the technical stuff is, there's really three big use cases that we see over and over and over again with our customers. Our customers, when they look to VMware Cloud on AWS, generally fall into one of these three scenarios. Not all of them, but many of them do. And the first one is maintain and expand. You have your on-premises data center, you're either running out of space or needing additional locations. And so they look to VMware Cloud on AWS to expand their footprint there. The second one is consolidation migrations. We see customers that are consolidating between multiple data centers and potentially needing a larger footprint somewhere, and they don't want to go out and get an additional colo or sign another agreement for building another data center or leasing another data center. We see customers who purchase through either mergers and acquisitions or straight up purchasing additional hardware that need somewhere to put that. And we see them using VMware Cloud on AWS as a location for that. And the third scenario here is flexibility as needed. People running dev test workloads, people needing to run workloads temporarily. Maybe it's bursting up to the cloud. Maybe it's running workloads for several given weeks or given months. But it gives you the ability to do hourly on demand as needed by your customers, or by you, the customer. So let's get into kind of what we have here and how this whole product works. So the Cloud SDDC. Inside of VMware Cloud on AWS, when you spin up a software-defined data center, what do you get? First, let's talk about the configuration. So if I spin up an SDDC that has vCenter, vSAN, NSX, and all the rest of my workloads running in there, I can have up to 10 clusters within that SDDC or within that vCenter. Okay, each of those clusters can support 16 ESXi hosts, so you're looking at a total of 160 ESXi hosts per vCenter server. Now, the only cluster that is actually running any of the management workloads is going to be cluster 01. So out of cluster 01, and you'll see this in another slide, there will be a small portion of resources that are set aside in a resource pool that allow us to run NSX and the NSX edges, the NSX controllers, vCenter, and a number of other workloads if you have, for example, site recovery or HCX in your environment. All those workloads will reside in that resource pool in cluster 1. But if you go ahead and add additional clusters into your environment, all of the resources from there, 100% of the resources, are dedicated to the customer workloads. The great thing about the organization or the hierarchy of VMware Cloud on AWS is you can have multiple SDDCs within your account. So as you can see here, if you needed more hosts, you could also spin up an additional SDDC, and you can run, as many of those. You can do 10 SDDCs per logical grouping or logical account called an organization as you choose. So how does that look? Well, this is the VMware Cloud on AWS console, and as you can see here, I'm logged in as myself, and these are the two software-defined data centers that I have running in my account. We can see that they're side by side, and I can click on their titles to go dive into them more and to log into the vCenter or add additional hosts or work with the networking. And I can have up to 10 here in this page. From a cluster perspective, if I click into my VMC-core-SDDC, I can see down below I've got cluster 1 and cluster 2. Each of them have 3 hosts. So as I choose to add additional clusters, they will show up inside of the SDDC dashboard page down below. And this is more for you to be able to perform actions like adding or removing additional hosts from those clusters, or removing the clusters and adding the clusters themselves. All the rest of the management and administration is done within vCenter. So how does this work? For a customer, you have the ability to go ahead and add anywhere between 1 and 13 hosts per cluster, because with a 3-node minimum, those are the options that you have. The great thing about this is, unlike in an on-prem environment, you do not have to worry about a multi-month acquisition to acquire the budget, make the purchase, have it shipped, have it brought to the data center, racked and stacked and configured. An ESXi host is added within minutes, and generally we see here between 5 and 10 minutes. Sometimes, with a few other minutes in there, depending on what's going on. But on average, we see between 5 and 10 minutes to add additional hosts. So from an on-prem perspective, shrinking that time from 9 months or so down to about 10 minutes is great flexibility for our customers. So what does the cluster configuration look like? Well, if we use these a 3-node cluster that we showed before, you're looking at about 108 cores and 1.5 terabytes of RAM. If we expand that all the way up to a 16-node cluster, you can see that jumps up to 576 cores and 8.2 terabytes of RAM. These are all using dual socket motherboards with Intel E5 2686 processors, and hyperthreading is actually disabled by default. And we'll get into more about the processors and memory here in just a minute. The DRS configuration here is enabled by default. That's what gives us the ability to do resource pools and to be able to manage your workloads and allow them to load balance appropriately across all your hosts. DPM is disabled, and we have 2 specific resource pools that are created by default when you deploy your SDDC. So as you can see on the left-hand side, there's a portion of the environment that is controlled and managed by VMware, and that allows us to do things like be the administrators, do the upgrades, do the firmware updates, troubleshoot. All of the portions that you would have to worry about in an on-premises environment are taken over and run by VMware. The rest of the environment is managed by you, the customer. So the other resource pools with all the additional capacity for the cluster are all able to be 100% managed by you. Another cool feature of VMware Cloud on AWS is the way that we do automated host remediation. Now, what that means is if a host is starting to go bad, if we can sense that via the logs or any alerts that we get that there's a potential issue with a host, we will go ahead and add an additional host into the cluster. We'll configure it and have it start syncing the vSAN data store. And once the sync is complete, we'll kick out the potentially bad host, and there's nothing that you need to worry about. So instead of having additional host capacity in each of the clusters for those just-in-case failures, you really have the ability to leverage the cloud here and have hosts added in automatically as needed. So as you can see here, in this situation with automated hardware remediation, we detect a problem, we add in that additional host, and we kick out the bad host, and life continues to go on as normal. From an HA perspective, we use vSphere HA in several different scenarios, one of which we'll talk about a little bit later in this webinar for stretch clusters. But as you can see, I'm not going to read through this slide, but we do leverage vSphere HA. We set the host failures to tolerate to 1. And in the event of a host isolation response, we do just power off those VMs and restart the VMs onto other hosts that are still connected. Our customers have come to us and said, we really like the environment, we really like the product, but being able to license an entire cluster and all the cores in that cluster can be very pricey for us. Do you have any other options? One of the things that we've talked about and that we've announced here in preview is custom CPU core counts. And what that allows us to do is add in, for example, an additional cluster into your SDDC and actually go in and shut off specific cores or a number of cores that the customer chooses for us from the BIOS layer, meaning that there's absolutely no way that these cores can be used, powered on, even for a split second by any of the applications that are being licensed. So although you've got a host that maybe has, for example, 36 cores, if you only want to license, for example, 8 of those, then we can go ahead and work with you to go ahead and disable those cores so that your licenses are only being used for the cores that you want to actually license and leverage. Elastic DRS is another one. So Elastic DRS plays along the same lines as regular vSphere DRS in the sense that with vSphere DRS, we're able to load balance workloads across hosts. But because we're able to take advantage of the cloud and everything there with the cloud APIs and AWS's additional hosts in each of these regions, we can leverage Elastic DRS to, instead of load balancing the virtual machines, allow us to add additional hosts or remove hosts as needed. So if, for example, my hosts in a cluster exceed a specific threshold of CPU memory or storage for a specific amount of time, I can enable Elastic DRS to go in and expand my cluster to ease the burden of the resource utilization for all my workloads. And as you can see here, I have two different options. I can optimize for best performance and I can optimize for lowest cost. And when you choose either of these two options, you will also be able to choose the minimum cluster size and the maximum cluster size. So depending on what's going on with your workloads, you're able to come in here and say, do not exceed a specific size of the cluster. And really how that works is we go in and we say, okay, at the cluster level, you can enable this. As you can see here, it's disabled by default. And it will automatically scan every 5 minutes, just as DRS has done in the past, and monitor the utilization of the resources. Now, it will scale up when any of the resources that we've talked about, the CPU, the memory, and the storage, are exceeding the thresholds. But it will only scale down when all of the resources are consistently below the specified threshold. So it's not going to try and shrink down an environment because, let's say, for example, that your CPU was the reason why it expanded your cluster. If all of a sudden your storage or your memory is above the threshold, but your CPU has fallen below the threshold, it won't scale down the cluster until all of those resources are below the threshold there. And that's something we'll talk about here in these next two slides. So the two options are optimize for best performance and optimize for cost. So with optimize for best performance, it's going to be less eager to remove a host, meaning it's going to have more leeway to give your VMs the performance that they require, and less aggressive about trying to load balance those workloads and squeeze them back into N-1 like you would have had in a previous state. Now, with optimize for lower cost, this is actually going to put more emphasis on being able to remove the host as soon as possible. So for customers who maybe have a 1 year or a 3 year commit on the regular 3 nodes, adding in an additional host via Elastic DRS may be an hourly host. And in that case, some customers may say, you know what, I want this to make sure that my workloads are good. Maybe I only want to allow the maximum cluster size to be where I'm currently at, +2 or +1. But then if you optimize for lower cost, Elastic DRS will work to shrink it back down to the minimum size as soon as possible. Now, one of the things that we mentioned and is currently in preview is the ability to run Elastic vSAN on R5 metal instances. So unlike regular i3 metal that we're running, the i3 metals, when you deploy your SDDC, have 16 terabytes of NVMe storage per host. We have customers that have said, what if I want larger or smaller amounts of storage per host? That's where R5 metal comes into play. And R5 metal doesn't have any local storage. Instead, R5 metal connects to Amazon's EBS or Elastic Block Storage to allow you to choose the amount of storage that you want in increments of 5 terabytes. So the smallest portion per host that we're allowing right now is 15 terabytes, all the way up to 35 terabytes per host. Now, there's a few really, really cool things that occur with us leveraging EBS-backed vSAN that we'll, I believe, have in this next slide right over here. So the R5 metal instances are a little bit different than the i3s that we use. So the R5 has 48 cores per host, but it has a lot more RAM than the original host did. So this is more memory heavy as far as your ESXi hosts go. A 3-node, as you can see here, would end up having about 2.3 terabytes of RAM, anywhere between 15 terabytes and 105 terabytes of raw storage. And if you scale that up to 16 terabytes, you're looking at 80 terabytes to 560 terabytes of raw storage. Now, like I said before, with automated host remediation, if a host is looking like there's a potential health issue with the host, we'll go ahead and add that host, or we'll add an additional host into the cluster, sync the vSAN data, everything we need there, and kick out the bad host. Well, because EBS is actually not tied specifically to the internal operations of a host, we can actually add and remove hosts very quickly and not have to do any sort of resync, because the storage is not connected to the server itself. So if we do run into reasons for hardware remediation, we can go ahead and do that very, very easily and very quickly using the R5 metal instances. So what does the storage configuration look like? From the i3s that I was talking about, each host has 8 NVMe devices that are 2 terabytes apiece. So you're looking at roughly 30 terabytes of raw capacity on a 3-node cluster. We'll talk about the reasons why there, as well as up to 160 terabytes in the in a 16-node cluster. Now, the management virtual machines that I talked about before take up about 1% of the total vSAN data store on the i3 environment. So as you can see, it's really not very much. The usable storage here, the customers can go ahead and set SPBM, or storage policy-based management policies, to choose what type of essentially RAID that they want to use for the virtual machines. So as you can see here, each host has 2 disk groups, as well as a cache tier and capacity tier. So the caching tier is the reason why you only have about 10.2 terabytes of usable storage per host, because we also have the caching involved per host for vSAN. And as you go through and choose what type of storage policies you want for your virtual machines, you can choose between RAID 1, 5, and 6. If we want to look at how vSAN is calculated here, we have a total of 10.7 terabytes of usable raw storage for capacity. When you take into account vSAN metadata overhead, we shrink that down to about 10.2. Recommended slack space, we give it about 20% slack, and then the recommended usable, you can see here, is about 8 terabytes. But if you're using RAID 5, you can see how much of an overhead that is. So the recommended effective capacity here is about 6 terabytes of storage. So I mentioned the stretch clusters and a little bit at the beginning, but let's talk a little bit more about what this looks like from within AWS's regions. So when you deploy a standard SDDC, it's actually all going into a single availability zone. And that's what you'd see in an on-prem environment as well. In an on-prem environment, you most likely only have a single data center, and if something happens there, you have an outage. Now, most of our customers are happy with being able to run in an AWS availability zone, but we've had other customers that said, hey, we want even more availability. Can we get more 9s? Can we be even more resilient? So we've gone ahead and we've created the stretch cluster, the multi-AZ deployment. And what this does is it evenly distributes your workloads and your hosts across 2 different availability zones. Those availability zones are chosen by you when you deploy, and then a 3rd availability zone is used for a witness node, and we select that ourselves. Most regions have 3 availability zones. Some of them have more. And for those regions that have more availability zones, we choose the additional AZ for the witness node. But what we have here is the ability to synchronously write to both availability zones, which means that in the event of any sort of outage in an availability zone, your RPO is 0. The data is synchronously written to both AZs. The RTO for the affected availability zone is just the amount of time it takes for a vSphere HA restart of those virtual machines. So just like if you had a host go down in your current data center in a cluster, the amount of time it takes for vSphere HA to restart those virtual machines is the RTO that you would have in a stretch cluster. So this is really great because for customers who don't have the budget or the time to repurpose their workloads, their applications for this additional resiliency at the application level, we're able to do all of this at the infrastructure level. So the cross-AZ traffic, right? You have a virtual machine. As it writes, it's synchronously writing to both availability zones. But the read is going to come from the side or the site where the VM is currently residing. So this is also called read locality. And what we're doing here is essentially we're going to take the read from the fastest and closest location possible. Now vSAN, you can go ahead and choose what type of site affinity you want. So there's actually 4 different types here. We're not going to take time to go through all of these different options, but we'll go through some of these very quickly. You can do dual site mirroring, which essentially mirrors all of your data. Those synchronous writes go to both of your AZs. If you choose not to do any sort of mirroring, you can choose to keep the data on the preferred site. So for example, let's say that the majority of your workloads and AWS services were running in the first AZ. Maybe you would choose to keep all the data in that AZ as well. You also have the ability to choose to keep that data in the non-preferred AZ. So there's a number of different ways that you can set up your stretch clusters here that is taking advantage of AWS's multi-AZ designs. So what would a failure look like for a workload in a multi-AZ environment? In this case, well, I'm getting ahead of myself. We're going to jump ahead here on one of these slides. All right. So in the event of a host failure within a cluster, within an AZ, you're going to see that vSphere HA is going to go ahead and kick in for those virtual machines that were on the affected host, and AWS will add in another ESXi host for you. It'll sync the data, and everything will go back to normal. If you have a witness node failure, what you'll see is that vSAN will rebuild a witness in the third AZ as well, and everything continues to run as normal. And in the case of an AZ failure, what you would see here is that an AZ goes down, and the virtual machines running on that side would then restart into the secondary availability zone. Once that availability zone is restored, all the data is going to resync across from the healthy AZ, and then the user can go ahead and move workloads back to the preferred site. All right, so let's talk about the network configuration. So AWS has their own networking underneath the covers for each of the hosts. Each of these hosts have a 25 gigabit ENA, and that allows us to do a number of different things across the board, not only between our hosts, but between our hosts and AWS services. On top of that physical layer, we have NSX. Now, NSX allows us to do a number of different things, not just microsegmentation, not just our VPN connectivity, layer 2 stretches. We're able to go ahead and actually do a guest introspection, add in as many logical networks as we choose, and a number of other items. As you can see here in the screenshot from my SDDC, we kind of have a graphical view of what our environment looks like. So you can see on the left-hand side our VMware Cloud on AWS software-defined data center. On the right-hand side, you can see the internet, our on-prem environment, and an Amazon VPC that is associated with this SDDC. Now, from a networking and compute perspective, we have 2 different portions of the SDDC carved up. We have the management, which has the management resource pool, the management data store, and then we have the compute We've got the compute data store for you to run all your workloads on and a compute resource pool. But we also have a compute and management gateway. So within the management gateway, all of our management workloads reside there. That includes vCenter and NSX, HCX, site recovery, anything that we use to provide and power your SDDC will run in there. And then everything else from a networking perspective is done from within the compute gateway for our customers. And you can see here I have a segment. I've got multiple firewall rules, and I have direct connect set up to my SDDC. Now, in previous versions of VMware Cloud on AWS, to be able to talk with the vCenter or leverage things like Power CLI, as well as tools and APIs from the ESXi hosts, you'd actually have to create a VPN connection between the two gateways. With NSXT, which we announced back in August, we're able to go ahead and open that up already for our customers, so that there's no need for you to do any sort of VPN. Your workloads can communicate and leverage the APIs of the VMware stack across the two different gateways. So from an NSX perspective here, what you'll see is you've got multiple controllers. You have a controller for each of the hosts. You've got your NSX edges running in high availability mode. So we've got 2 of them. You have your NSX manager, and that's basically the standard default for the networking side. Now, all these, as you can see, are in the management resource pool. This means that you won't see them running next to your own workloads, and you as the customer don't have permission to go in and delete these workloads, thank goodness, right? All you need to worry about here is you have read-only access. You can see that they're running, and if there's any issues with any of these, you can get right into the intercom chat support and start chatting with the help tech support, and they can take care of the issues that you may have. So on the left-hand side, you'll see what we've had in the past with NSXV and connected to an AWS VPC. On the right-hand side, you can see what it now looks like with NSXT, and that it's actually simplified. So what you'll see is, as we focus on NSXT here, the VMware Cloud on AWS SDDC is on the right-hand side of the right image with a connected VPC. What this allows us to do is when you deploy your SDDC, you can choose an AWS account and a VPC from that account that this SDDC can interact with. Now, that 25 gigabit connection between the ESXi hosts and the AWS data center has what's called an ENI, or an Elastic Network Interface, that allows us to do some pretty cool things where we can go ahead and have workloads running within the SDDC interact with native AWS services without crossing the internet gateway. So doing everything behind the scenes. That may be things like interacting with S3, maybe communicating with EC2 instances. It could be leveraging the Elastic Load Balancers. There's a number of different options that you can take, and really just looking at the AWS services, say, all right, which ones here meet my needs and which ones would be great to tie into my workloads running in VMware Cloud on AWS. Now, that ENI comes directly into the SDDC, and from there, the routing is all done as long as you open up the firewall rules, just like they were on the same network. So we'll talk a little bit more about the routing table here in a minute, but as you can see here, we've got, you know, an EC2 instance talking with a virtual machine. And obviously this is a little more simplified view of how that would look. But if you had an EC2 instance that needed to talk with vCenter, or an EC2 instance with Power CLI installed and wanted to interact with that environment, you can see how that traffic would traverse the ENI and work with the SDDC. Now, for customers that want to leverage Direct Connect, we have customers that already have Direct Connect lines into AWS. We have customers that want to be able to do vMotions from on-prem to the cloud. And for those that want to do vMotion, we've actually stated that Direct Connect is one of the prerequisites for that. So what would that actually look like? Well, it's pretty simple and straightforward here. So from your on-premises environment up to your Direct Connect location, you have two options. Now you can use a public VIF or virtual interface or a private VIF, virtual interface. And I'll just refer to it from a VIF from now on. But the advantages to leveraging a private VIF is that you have no need for additional VPN connectivity across the direct connect line. So the private VIF will actually go ahead and run that connection from your on-prem environment all the way into the VPC of VMware Cloud on AWS. You'll leverage external BGP that will allow you to also route traffic back down through to your on-prem environment and out that way if you choose to do that. There's a number of options that you have as far as how you configure. But if you already have a direct connect set up, all you have to do is attach an additional private VIF to VMware Cloud on AWS through the UI, and you're good to go. So we'll, just for the sake of time, we're going to jump past some of this. But essentially, if you are using a private VIF, all of your vMotion traffic, all of your traffic for virtual machines talking with virtual machines on-prem, all the traffic, 100% of it will go through that private VIF and through Direct Connect. Whereas in the past, only a portion of that, the vMotion ESX management, would go through Direct Connect, and the rest had to go over a VPN. For those who don't have Direct Connect and just want connectivity back to their on-prem environment, all you need is a VPN that allows you to do IPsec. So that may be a software VPN, that may be a hardware VPN. It really doesn't matter as long as you can meet the IPsec requirements. Now, what you'll do here is you'll set up a VPN tunnel, and you'll walk through that from the VMware Cloud on AWS console. It's very straightforward there, and then you'll just add the same settings that are created there to your on-prem side, and it will establish the VPN tunnel for you. And once you have the VPN tunnel up, you can do things like allow workloads from on-premises to talk with workloads running in the cloud. You will be able to do things like hybrid linked mode, where you're able to take a look and manage both environments from one specific vSphere client. The VPN tunnel makes things really nice and easy for you to manage multiple sites without having to have multiple tabs. So some of the advantages here to using IPsec VPN is you actually can set up a redundant VPN with NSXT. So if you have issues with one of your VPNs, you don't lose connectivity between your two environments. Obviously, same type of thing happens with new networks that are created. You can essentially broadcast those across your IPsec connection, and there's not really anything new or additional that you have to do there. So we've talked a little bit in depth about the storage and the networking of the hosts, but what do you do once you deploy an SDDC? Once you have the connectivity set up, what's next? So from here, one of the things that we talk about with our customers is an easy and quick way to get some of your templates or your OVAs or your workloads up to your SDDC is to leverage Content Library. Now, the great thing about Content Library is it's, first off, an easy way to organize all of your ISOs and scripts and OVAs and OVFs that you have on-prem, but it also allows you to broadcast that and publish that out to other vCenter servers that you have. So in this instance, we can take our on-prem SDDC, create a content library with all of our gold builds that we use on-prem, and we can turn that into a publisher content library. And as soon as we have our SDDC set up in an AWS region, we can log into that vCenter server and turn that into a subscriber vCenter server that allows us to then start replicating and copying all those builds up till you have them locally in that new vCenter server, and you can start deploying directly from that content library once those have been uploaded. Like I said before with hybrid linked mode, this is probably one of the most compelling reasons why customers are excited about VMware Cloud and AWS, is the fact that you can have multiple SDDCs or multiple vCenters all within a single pane of glass. Now, in the past, you've been able to do that in an on-prem environment as long as your vCenter servers are part of the same SSO domain. The problem is when you go to another cloud, or for example, VMware Cloud on AWS, you don't have a way to specify the SSO domain for VMware Cloud on AWS. But what we've done is we've gone ahead and we've created what's called hybrid linked mode as well as cloud gateway. They both accomplish the same thing here that allows us to actually merge two SSO domains together and leverage, for example, your identity source, your identity store from on-premises to log into VMware Cloud on AWS and see both environments within the same vSphere client. This allows us to do other things like cold migrations and vMotions directly from the UI. Now, a few things with hybrid linked mode. Okay, you need to be at least on vSphere 6.5. This works with the embedded PSC, and I had already mentioned that it allows you to take multiple SSO domains, meaning one from on-premises and VMware Cloud on AWS, and link them together. And as you can see in the image here, I've right-clicked on a workload, and I can click on migrate. And as I go through that migration workflow, I actually can see all the resources from both environments and determine where I want that workload to end up. So as far as connectivity back to on-premises, we already talked about the IPsec VPN. We already talked about Direct Connect. But if you want to do vMotions, the other thing that you'll need is a layer 2 VPN or a layer 2 stretch network. And all that really is doing is it's allowing us to stretch your network from on-premises up to the cloud so that you have your workload continue to run with zero downtime. Whereas if you tried to vMotion workloads without a layer 2 stretch, once they got to the target site, they wouldn't be routable anymore. Okay, you'd have to re-IP those. Now, how can I do a layer 2 stretch? If you've got NSX on premises, you can just leverage NSX to create that layer 2 stretch. But if you don't have NSX on premises, you can go and download the NSX Edge appliance, which is free. You don't need NSX to do that. And it allows you to create that connectivity. So you download that and upload it into your on-premises environment and configure that for layer 2 connectivity up to VMware Cloud on AWS. And that would allow you to do your vMotion migrations. Now, if you use vMotion, we do require at least 250 megabits per second of bandwidth per vMotion. So depending on the size of pipes in and out of your data center, vMotions might not be the best way of doing things. Now, granted, it's a live migration with zero downtime, which is fantastic. But as we all know from vMotions on premises, vMotion is pretty greedy when it comes to its bandwidth. The idea here is that it pushes across as much of the data as it can, copies it across as quickly as possible so that you can begin running and not have to have as many deltas sent across as well. You know, if this takes a long time to vMotion a workload and the workload itself is having a lot of writes, for example, vMotion will have to send a lot of delta changes along the way as well, and that can significantly increase the amount of time it takes for vMotion to occur. So we require at least 250 megabits of bandwidth there. But once again, like I said, you don't need to power off your workloads. You don't need to re-IP them. It just works. So when you're migrating workloads, your options are with the layer 3 IPsec VPN, meaning you don't have your layer 2 or direct connect setup, you can do cold migrations. You can power down the virtual machine and migrate across just fine. With layer 2 VPN, you're able to do those live migrations, but keep in mind that long distance vMotion rules do apply here. And direct connect is also used for those vMotions. Another option that we have is called HCX. Now, HCX is an appliance that you would install on-prem and a cloud service that is run by VMware that allows you to not only do things like vMotion and cold migrations, but it allows you to do everything in bulk. There's also replicated assisted vMotion, which is the ability to go ahead and replicate as many virtual machines as you want to a target site, but instead of powering them off and then powering them back on in the target location, we leverage the functionality of vMotion to just flip those last few bits and keep your workload running. So instead of needing to use vMotion for every single virtual machine, we can seed the data in the background and then choose when to flip those bits over and keep them running. And we've seen customers move hundreds and hundreds of workloads from on-premises to VMware Cloud on AWS with zero downtime using HCX. One of the cool features with HCX is the fact that unlike a regular vMotion that requires 250 megabits per second, leveraging HCX in vMotion only requires 100 megabits per second. We also have things such as it's escaping my memory right now. Compression and WAN optimization with HCX. So we can stretch our layer 2 networks directly from within HCX. We can migrate everything in bulk, and we have the ability to leverage things such as compression and WAN optimization to do those. All right, let's talk a little bit about the VPC setup. So if you're unfamiliar with AWS, VPC stands for Virtual Private Cloud. And it's essentially a logical organization, or I mean, you could call it maybe a vApp on steroids if you're more familiar with the VMware vApp. But a VPC allows you to create a bunch of resources and leverage them within a logical construct. Like I said earlier, your SDDC is tied to a VPC on deploy. So for customers who are new to AWS, they've had the questions of, well, how does this work? It's pretty straightforward. So here you can see I choose a region within AWS, and currently in this case I'm in the Oregon region, and then I can go ahead and create a VPC. Now that VPC, all I've really done is specified a CIDR block or a network subnet that is housed with this VPC. And then from there, I can go ahead and create additional subnets within that VPC. Now, each subnet is actually related to one of AWS's availability zones. And something to consider here is if I place my workloads in the same availability zone as my SDDC, and my VMs are talking with my AWS services, then I have 0 cross-AZ data charges. However, for example, let's say that I had the very top row here, US West 2A availability zone. Let's say that I had the majority of my AWS services running there, and I deployed my SDDC into US West 2B. That's fine, but if you want your workloads to communicate and interact with one another, just realize that you may have additional cross-AZ data charges. And that's normal within AWS as well. This is nothing specific to VMware Cloud on AWS. Like I said before, your SDDC deploys into a single availability zone unless you specifically choose to do a multi-AZ deploy, which would go across multiple AZs. Now this is interesting, and customers have thought this is really nice to have, right? Is the ability to go ahead and automatically add to your VPC route table when a logical network is created within vCenter. So when we use NSX and we create a new logical network for our workloads to be running on, it will also come out and it will update the route table associated with your VPC so that AWS services can communicate with virtual machines on that network. Now, as you can see here, if you zoom in a little bit, the target is an ENI. So rather than specifying a specific IP address of an ESXi host, what we're doing is it's assigned to one of the Elastic Network interfaces tied to one of your ESXi hosts, and all the traffic will traverse that ENI and make its way over to your virtual machine. But as I add more and more logical networks internally within vCenter, I will see those routes being added here inside of my AWS route table. The last portion I'm going to touch on within the VPCs are AWS endpoints. So like I mentioned before, being able to leverage the Elastic Network interface within AWS, you're able to go ahead and traverse the ENI rather than going through the internet gateway. So for things such as S3, S3 is great at being able to handle a bunch of data thrown at it. It's cheap storage, it's wonderful, and currently you pay monthly for the amount of storage you're consuming as well as any egress charges, right? Any data that you pull out of that S3 bucket to your on-premises environment or wherever it may be, you're going to pay per gigabyte on those downloads. If you use a S3 endpoint, it will allow that traffic to go across the ENI, which means that you don't have any of those egress charges. So especially if you're a company that leverages S3 a lot, if you start leveraging that with an S3 endpoint within your SDDC, you'll actually be able to get away with no egress charges into the virtual machines running in VMware Cloud on AWS. All right, we have about 9 minutes left, so I'm going to try and get through just a couple more things here and then leave a few minutes for Q&A. So let's jump through the administration portion of this. So currently this is run as a service by VMware. So everything from the hardware to the software to the support, everything is being done for you through VMware. Now, VMware works with AWS on the back end. We make sure to pay them, but everything goes through us, which also means the bill will come directly through VMware Cloud on AWS. All the APIs, everything that you'll use, all being run from VMware. We go ahead and we do all the maintenance for you. We do all the support, and you just continue to work with us as normal. One of the great things that we have in the UI is this in-product support experience. So not only can you click on a little button in the bottom right-hand corner of your screen to start chatting with VMware support, but you can bring up this intelligent search, which depending on which page of the vSphere client you're on and what you start typing in, it will bring back answers, it will bring back knowledge-based articles, it will bring back documentation, and it's very intelligent. So if I'm currently on a page for my networking, right, it's going to automatically start bringing up things related to networking for me. So it's not a static support page. Then you can see other things like quick links to the community, as well as seeing the service health. All right, so as far as the account structure is concerned here, there's two different AWS accounts that are in play when you deploy an SDDC. The first one is the VMware Cloud VPC account. So when you deploy an SDDC, that's going into a VPC owned by VMware. We take care of that. We run everything in there, but we give you access to vCenter, which is all you really need there. The second VPC is your own VPC, and that's the one that you associate on deployment of the SDDC that allows your SDDC or your virtual machines to communicate with AWS services that you have running in your own AWS account. Like I said about cross AZ charges, here's a very simple and easy to use slide that pretty much shows what types of costs you incur going different directions. So I won't spend a lot of time on here. You can screenshot this or hopefully come back and watch a recording of this afterwards. But going between regions, you obviously have a cross AZ charge. But going between VMware Cloud on AWS VPC and your own VPC that are a part of the same availability zone, it's free. You can see which portions of that will come to you in your bill from VMware Cloud on AWS and which part are just normal with your own use of AWS services. We already talked about the access model. We'll skip through some of these here. Just real quick, the organizations within VMware Cloud on AWS, also referred to as orgs, it's a logical grouping that allows you to add other users to leverage VMware Cloud on AWS services. So I can add additional coworkers into my org and deploy an SDDC that they would then have access to. I can deploy an org or create an org and invite people to use things such as log intelligence or hybrid cloud extension, HCX. And I can have multiple SDDCs within that org. Essentially, it's a payment tenant as well as a way for you to group logically the different people that would be associated with that SDDC. When you look within vCenter, you'll see that we have a default folder structure. So we have a folder of management VMs and network VMs, and those ones, like I said, only have read-only access for you, the customer. But templates and workloads and any other folders that you create are all up to you to use as you please. Same with discovered virtual machines. All of these have different permissions on them, but you've got to understand that the management and networking virtual machines, pretty much your workload, your management workloads, are in a state that allow you to see them, but not do anything to them that would negatively impact the performance of your SDDC. Last but not least, we'll talk very quickly about the APIs. So VMware Cloud on AWS, we've got 3 different API surfaces that you can use to fully automate pretty much anything that you want to do. So you've got your console.cloud.vmware.com, which is essentially where you go in to authenticate with any of the VMware Cloud services. Once you authenticate there and you've got an auth token, you really don't need to do anything else at that level. So you'll take that auth token and use that auth token to work at the vmc.vmware.com level. And here you can deploy your SDDCs, you can add clusters and add hosts and do networking and add users. All those regular administrative activities occur here at the VMC API surface. And the third one that you see here is your vCenter. This is the same thing that you'd have on premises. So if you're already using things like PowerCLI or REST commands against your vCenter server, that's the third API surface that you'd use. We pretty much talked about this. The one thing I'll point out here is the base URL. So if you want to work directly with the REST API, the base URL for working with the API is vmc.vmware.com/vmc/API. Now, if you want to be able to do some of this from within the UI, from within VMware Cloud on AWS, you can actually go to what's called Developer Center, and we have a tab in there called API Explorer that allows you to see every single API that is open for you to use and to try it out directly from the UI. So rather than having to write your own scripts, if it's Python or PowerCLI or REST, Postman, whatever you're doing, this is a very quick and easy way for you to test an API without actually having to write the code for it and see what you need, what type of statement you'd get back out of that, what the response or payload would be. So with all of this, you'll be able to go full circle and automate everything from deployment of an SDDC to deployment of VMs from content library or just creating new virtual machines, even all the way through doing vMotions or cold migrations from one site to the other, all from a CLI. So with that, that's pretty much the end of this presentation. Hopefully your brains are not bleeding at this point. We were able to go deeper into the hosts, the networking, the storage, into HCX, how we do migrations, workload mobility, and how we connect to our on-prem environments. We talked about our VPC structure, and we talked about the APIs. And with that, we'll open this up for some questions for the remaining time that we have. And thank you all for joining me.